This is the Exponent's Law math project. So the first rule is the product rule, which states that if m and n are positive integers and a is a real number, a to the power of m times a to the power of n, it becomes a to the power of m plus n. So you would add the integers. So for an example, if I had an 5 to the power of 2 times 5 to the power of 8, I would add the exponents to make 10, and then keep the base, so that would be 5 to the 10th power. So then the next rule is the power rule for exponents, which states if m and n are positive integers and a is a real number, y to the power of m in parentheses to the power of n, you would multiply the exponents, so m times n, and then you'd keep the base. So then for an example, if I had y to the power of 6 in parentheses to the power of 2, I would multiply 6 times 2, which equals 12, and keep the y base, which is y to the power of 12. The next rule is the power rule for the product rule, which states if n is a positive integer and a and b are real numbers, a and b in parentheses to the power of n, a to the power of n, and then b to the power of n, and you have your answer. So for an example, if I had 5x in parentheses to the power of 4, I would do 5 to the power of 4 and x to the power of 4. So 5 to the power of 4 is 625, and then x to the power of 4 is just x to the power of 4. So my answer would be 625x to the power of 4. My next rule is the power rule, power of a quotient rule, which states if n is a positive integer and a and c are real numbers, then a over c in parentheses to the power of n, you do a to the power of n, and then c to the power of n. So for an example, if I had 2/3 in parentheses to the power of 4, I would do 2 times to add 2 to the power of 4, and then 3 to the power of 4. So if I had 2 to the power of 4, it'd come out to 16, then 3 to the power of 4 is 81. So if you had a different number, you'd most likely simplify, but 16 over 81 is already in its simplest form, so you do not have to simplify. The next rule is the quotient rule for exponents, which states if m and n are positive integers and a is a real number, a to the power of m over a to the power of n, it becomes a to the power of m minus n. So you subtract your integers, your exponents. You'd subtract your exponents. So for an example, if I had x over x to the power of 6 over x to the power of 3, I would subtract 3 from 6, which equals 3, so my answer is x to the power of 3, simplified. The next rule is the zero exponent rule, which simply states that if your exponent is 0, then it automatically equals 1, as long as the base is not 0. So for an example, if a to the power of 0, it just equals 1. So if I have 4 to the power of 0, it equals 1, and xs to the power of 0, it equals 1. The next rule is adding a polynomials, which states that to add polynomials, you just combine like terms. So for an example, if I had negative 3x2 plus 4x minus 1 plus 3x2 plus 2x plus 4, these would be in parentheses and these would be in parentheses. Just you can remove those and combine like terms. So I can combine negative 3x. I can combine negative 3x, negative 3x2, and 3x2 plus 3x2. Or actually, that should be a negative 3x2. So I would combine those, and that comes out to negative 6x2, and then I can combine 4x and 2x, which comes out to plus 6x, and then lastly, I can do negative 1 plus 4, which comes out to plus 3, which my answer is then negative 6x to the power of 2 plus 6x plus 3. The next rule is subtracting polynomials, and that states that to subtract two polynomials, change the signs of the terms of the polynomials and then by subtracting and then add. So for an example, if I had 6x minus 3 minus 4x minus 9, take away the parentheses and keep the first term, which is 6x minus 3, and then plus negative 4x, or just 6x minus 3 minus 4x, and then plus 9, because originally it was negative 9. So then you can just combine like terms. So 6x minus 4x is 2x, and then negative 3 and 9, which is plus 6. So that's the answer. Then the next rule is multiplying binomials and trinomials, which, so for multiplying two polynomials, multiply each term of the by the first term of polynomials by each term of the second polynomial and combine like terms. So you would multiply the first term, which is 4x plus 3 in parentheses, and then by 2x in parentheses minus 3. So how would you do that? You would do 4x times 2x in parentheses, and then next is 4x times negative 3 in parentheses. And then next you do 3 times 2x, moving on to like the second term, and then the last term is 3 to the power of negative 3. So you'd multiply the first term, 1 and 2, by excuse me. Yeah, then that would come out simplified 8x minus 12x plus 6x minus 9. So we have lots of combined terms, which come out to 2x minus 9. Now the next one is multiplying a binomial by a trinomial. This one is a little bit longer. So if you have in parentheses s plus 4 times 4s2 minus 4s plus 5, you would multiply first s by everything, and then 4 by everything. So then it would come out to s times 4s to the power of 2 in parentheses, next s times 4, negative 4s, then next s times 5 in parentheses, next you're moving on to the next part, which is the 4. So you're going to do 4 times negative 4s to the power of 2. Not negative. But then you do 4 times 4s, which is in parentheses, and then lastly, parentheses 4 times 5, which comes out to simplified. You combine like terms, so then you'd have 4s to the power of 3 minus 4s to the power of 2 plus 5s plus 16s to the power of 2 minus 16s plus 20, which then comes out simplified fully is 4s3 plus 12s to the power of 2 minus 11s plus 20, and that is after combining all like terms. Thank you.